Hi there, I'm Jamie and I'm going to teach you some math. Now wait, before you leave, I'll try to keep it simple, don't worry. Today we will be talking about SOHCAHTOA. Now what the heck is that? Well, I'll get to it. Let's just start small. First, we need to establish something. Polygons. A polygon is a plane shape with three or more straight sides and angles. This is a polygon. It has three sides and three angles. This particular polygon is what we call a triangle. A triangle. Tri meaning three and angle meaning, well, angle. Three angles. I mean, tri-side could also work, but it doesn't sound as catchy. Moving on. For this lesson, I'll be focusing on right triangles. Triangles where one angle is 90 degrees. A right angle. It can be any length, any size, as long as it always has a right angle on one of its corners. This is where the lesson officially begins. Now you can see there is a long side opposite to this right angle, not connected to it at all. This is the longest side of the right triangle. It has a name, the hypotenuse. Now let's say you wanted to determine the length of this hypotenuse. It's easy. First, let's give each side a letter. We'll call these two sides A and B, and the hypotenuse side C. If you wanted to determine this length of C, it would be the square root of A squared plus B squared. Simple. Punch that into your calculator, and you get the answer. And if you wanted to find the lengths of A or B, it would be the square root of C squared minus the other side squared. That is the side that you're not trying to find the length of. There you go. Now we're ready to talk about SOHCAHTOA. Just like the previous equation can help you solve missing lengths of the triangle, this rule can help you find missing angles. Now, these aren't just some random capital letters. They stand for something. SO stands for sine equals opposite over hypotenuse. CA stands for cosine equals adjacent over hypotenuse. And TOA means tangent equals opposite over adjacent. When you enter sine, cos, or tan and a number in your calculator, this is what it essentially does, and that's why it appears to give a random decimal number, because fractions are weird. Now to put SOHCAHTOA to use. Let's say you wanted to find this angle. We'll call it theta after the Greek letter. How would you find it? The other corners don't tell you which angle they are, well, except for the right angle, which is always 90 degrees, but it's not that much help. Hey, look, some of the sides are marked. Maybe they can help me. Well, guess what? They can. Remember SOHCAHTOA? But which one do you use? Well, the hypotenuse is marked, and so is the side facing opposite of theta. Opposite, hypotenuse. Hey, this is SO. We can use SO to solve this. Wait. I know what you're thinking. How can we use SO to solve it if the fraction is all we know? Don't we need to know the angle to solve sine? Well, there's a little thing called inverse. See that button on your calculator that says sine? Now look for the button that says sine to the minus 1. Is it an alternate function, or a different colored symbol above the sine button? Then, press the alternate function button. This is an inverse. It allows you to find the angle of a triangle when you already have the sine, cosine, or tangent of that angle. Press it, and voila! There's the angle. You just used SO to solve the problem. Congrats! CA and TOA are pretty much the same deal. Find which sides you can solve the angle with, use the appropriate inverse function, get your angle. Simple. Keep in mind, the 90-degree angle is always there, and every angle of any triangle always adds up to 180 degrees. So, if your teacher's lazy and you find they tell you to solve this angle on a right triangle using SOHCAHTOA but the other angle is already marked, you can easily do simple subtraction and get an easy answer from that. Of course, because of this, SOHCAHTOA only applies to triangles where none of the angles are marked and you have to find one of them. Now, this is the part where I'm supposed to give you a couple questions to solve, right? Maybe a right triangle, some side lengths, and an unmarked angle for you to find. But, of course, this is grade 11 math. So instead, here's a bunch of triangles glued together, and here's a few side lengths and one angle, and I'm going to ask you to solve this. Remember, you can also use the hypotenuse equation as well. Go ahead. Did you do it? Great! Here's the steps that you're supposed to use to solve this question. Don't worry, I'll show this after every question, but you should really try to do it on your own first. Here's another. Figure it out yet? One more. Don't worry, this is the last one. Solve it? Amazing! So there you have it, a quick lesson on SOHCAHTOA. Thanks for watching.